Hey everybody, it's Greenwood again with another tutorial video. In this video, I want to show you how to solve for a missing angle using trigonometry. So if you need more help with trig, go back and look at the previous videos, but let's get started. So you see I'm starting here with this 3, 4, 5 triangle. I've labeled this triangle in terms of x being my reference angle. So again, the hypotenuse is 5 here across from the right angle. My opposite side is across from the reference angle, that's 3. My adjacent is 4. And I've set up all these ratios, okay? So remember that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So I can use any of these three ratios to help me figure out what that angle measure is. So I'm just going to start by choosing sine. I'm going to write my ratio, and so sine is a relationship of any right triangle of the opposite side from an angle to the hypotenuse. And so you can think of it kind of as a percentage. What percent of the hypotenuse is the opposite? So 3/5, that's 0.6 as a decimal. So it's about 60% the size of this. So to solve for a missing angle, that's my variable. I need to use what's called inverse sine or arc sine. So I'm going to take the arc sine of 3 over, well, let's rewrite that because that's hard to read. That's a better 3, 3 over 5. Okay, so let me go ahead and open up my calculator here, drop it over. Okay, so I like this decimals calculator. So here's sine, cosine, and tangent, but if I want arc sine, I'm going to have to go over here to function, then find my sine -1, which is inverse sine or arc sine. So arc sine, and then 3 over 5. Let's use my keyboard for that, and it gives me the angle, 36.869. So that means x, which again is my reference angle, is 36.869 degrees. Okay. And so what's great about this is I can use any of these ratios because they're all referring to angle x. So let's try arc cosine of 4 over 5. So we do arc cosine. If you want to use the pad here, just go back to main. So 4 divided by 5. And I get the same value, which makes sense because I'm doing the arc cosine of the same reference angle. I didn't change my reference angle, okay? And so then let's do arc tangent. We'll just verify. So 3 over 4. Let's go back and look. 3 over 4. And we get the same exact value for all three of these ratios. And again, remember, that is because they're all referring to angle x, to my reference angle, okay? So I can use any one of these. And so where this is powerful is going to be in the next problem. Because what I'll notice here, reminder of your SOHCAHTOA, is I know my opposite and my adjacent, but I don't know my hypotenuse. So I chose the angle the problem wanted me to find out as my reference angle, so there's question mark. So again, opposite across from it, adjacent next to it, but not the hypotenuse. There's my hypotenuse. And so if I look at the sides I know the numbers for, I know the lengths of, I know the opposite's 8, I know the adjacent 17. So one little strategy you can use here, and I'll use some marker. I'm just going to put a little line under the sides that I know. And so to solve for trigonometry, I need to know 2 of the 3 parts between the angle and the 2 sides that are related. So for sine, I know opposite but not hypotenuse. So that means for this problem, I can't use that ratio. I don't have enough information. Cosine, the same thing will happen. I know adjacent, but again, not hypotenuse, so I can't use that one. I do know the opposite side and the adjacent side length, so I can use tangent. So that's kind of how you can analyze that process, and that's the next step, is to say which of these ratios can I use. In some situations, you'll be able to use more than one. In some situations, there's only one that's going to fit. So in this case, my only one that fits is tangent because I know opposite and adjacent. So tangent of my reference angle question mark is 8 over 17. So to solve, again, I'm going to do my inverse tangent or arc tangent of 8 over 17. There we go. And then again, now it becomes a quick calculator problem. So I'll go over and type in arc tan of 8 over 17 in my calculator. So function, we need arc tangent or inverse tangent. And then 8 divided by 17, boom, 25.201. So that means this question mark angle is 25.201 degrees. And so one great thing about this is there's lots of strategies. You can use the triangle sum theorem, you can use Pythagorean theorem, you can use trigonometry, and they all kind of work in right triangles to help you find different parts. So I could use a squared plus b squared equals c squared to find this hypotenuse. Then I'd have more choices here to find my angles with SOHCAHTOA. Also, so since I know this is 25.201 degrees, I can use the triangle sum theorem. So I know that my 90-degree angle plus the question mark angle plus this other one down here, let's just call it angle P. These three have to add up to 180 because the three interior angles in a triangle always add up to 180. So if I take 180 minus 90 minus 25.201, so 180 minus 90 minus this other angle, 25.201, that means my missing angle is approximately 64.799. This angle is about 64.8 degrees, about. I could use trigonometry to find that, so I could use tangent, but label it as this. So there's a lot of ways you can get there. So I hope this one helped you, and we'll see you in the next video. Bye.